Yep. See, it's already been recording for like 5 seconds. All right. Okay, here we go. Everyone can see that all right? Let me make it a little brighter. All right. All right, guys. So here's the thing. The last lesson, we were talking about box plots, right? We had what's in the middle? Box plot's favorite question. Hey, what's in the middle? Hey, what's in the middle? Hey, what's in the middle? That's all box plot cares about. Okay, what's in the middle? Now, we are now talking about we're looking at how spread out the data is from the mean median. Okay, how spread out the data is, right? So if you have your data really, really spread out, right, as far as like in this class what everyone's grade is, then it's information that could be helpful, right? So if I did our data and everybody had an A, right? That data would be skewed a little bit towards everyone doing better. If everyone had a D, which wouldn't happen, that would show as well data where like I need to change things, right? I need to change things up so everyone is closer to being towards a good grade. Okay. Now, the three methods we're going to look at. The first one is kind of an easy observation type method. We look graphically. We look how the graph is distributed. So distribution is just talking about where the data points are. So if this was a dot plot, these would be dots, and it would show that most people, were situated around the mean or the median. Okay, the dots would show that it's pretty balanced, it's symmetric. Okay, so this is, some people, teachers in education, want this. They want their most kids to have an average amount, and they want the kids that get the A's to be fewer, the kids that get the F's to be about the same as the A's. And that's a really old model. That's like so outdated. I feel bad even saying that education was that bad. That's not how it works, because we're not measuring mastery and compared to everyone else. We're measuring mastery and compared to standards and compared to what has to be accomplished. Right? There's plenty of room for everyone to get A's, and that's kind of a newer idea in education. This would be a class, right? I'm just looking at how it is spread out. This would be a class that if this was like a C, everybody is getting like a D, right? Most of the kids are getting a D. A few kids are doing good, right? And this is skew right, skew tail right. I like to think of it as tail because then I can draw a picture of my cat and whiskers. The tail goes over towards where the skew is, okay? It's like a cat wrapped in a blanket, okay? And then over here, this would be a class where it's probably closer to my class. I mean, my average score in my class are usually around 85, 83%, 80, like a low B. So this would be where most kids are getting a pretty good grade, and there's a few kids that just don't go to class and they're getting like a D. There's some kids that don't do homework, so they're getting a C. But, mostly the kids right here, the average is a little bit higher. It's skewed tail left, right? Because it has a few think of it as like dot values here. It has a few that skew the whole data, right? There's a few kids over here that make the data skewed, and it's then a tail left. Okay, I'm gonna keep drawing my cat, getting better at it. Now I got worse. Whatever. It's a cat wrapped in a blanket, okay? It's a cat burrito. No, that's horrible. Sorry I said that. All right. So graphically is just a matter of, hey, how do you just label how it's spread? It's spread symmetrically. It's skewed tail right, skewed tail left. And that's talking about, it's a little counterintuitive, but you got to think about which way the tail is going, okay? The tail is the key to help remember that. Okay, graphically, that is more of observation. The second method to look at how data is spread out, that's the main thing for today, is that how it is spread out, is looking at the IQR, the interquartile range. Remember, the interquartile range is just saying, well, what value is that Q1? What value is that Q3? And how far is that value? How far is it? This is 50%. When you have a box plot, 50% of your data fits into this range, okay? 50% fits here, right? So if this was, this actually shows that if we were talking about like baseball players getting to first base, this means that more people are getting to first base. This means that actually some aren't. Some are doing much worse. Some are doing much better, but it's so spread out. This has more spread, more variation because there's more different options within the box. Okay, more variation. Less spread like this, the values are less between Q1 and Q3. That means less variation. Okay, so it's a matter of thinking the box contains 50% of my data points, right? So if 50% of the data points fit right here, that means that there are a lot of people that had really close to the same number of getting to first base or the same score on the test. Okay, so it's a little more counterintuitive, but what you can think of it as, this is a few people spread out, right? A few people spread out. All the people are kind of in this box. This is less variation because they're all like crammed in there. It's like when in the 50s where they would try to cram into a telephone booth, which is where people used to have to pay money to speak on the telephone. There's less variation because more people are fitting within that 50% box. You see what I mean with that? Give me a thumbs up, sideways, down for that. That's like our first conceptual thing. Yeah, you see what I mean? It's just like there's more people. It's like clowns in a car, right? There's less variation if you're fitting them all into a car than if you have a big old bus. Okay. That is graphically, that is looking at our IQR from our box plot. And you're going to have to do a couple of those type problems. But this is the main thing. The main event is right here. This is talking about the mean absolute deviation. The mean absolute deviation. Don't worry. It's going to be okay. I just introduced it as if it's something we really have to work at. But you know what? We're good. We're good. We can do this all day long. All right. Now, this is just something different, something new. Let's see what it means here. Means. MAD is mean absolute deviation. What do these words mean? Mean is the average. Absolute is just like the distance from zero. We're going to think of it as the distance from the mean. Deviation is how far you deviate, how far you are from the mean. Like if you deviate from, if you were running track and you're in the first lane, and you decide, I want to run in the 9th lane, and you deviated over to the 9th lane, you're disqualified. But you're running in the lane with another person. They're like, why are you in the 9th lane? You say, I deviated 8 lanes. I don't know why. The steps to find this are, first, we're going to reorder from least to greatest. We're going to find the mean because we're finding how far the data points deviate, are different from the mean. Then we're going to find the absolute difference from that mean for each of my points. Each of my points here, I'm going to see, how far is each of these from the mean of all the points. And then I need to find the average of that, okay? It's kind of like finding the average twice. It's like with box plot that is obsessed with what's in the middle. Now we have something obsessed. The MAD is obsessed with the average. Well, what's the average? That's all they ever ask. All right, so follow with me. Let's reorder from least to greatest. Let's look at our values here. Game 4, this is games. This is points. Game 4 has 2. Game 1 has 3. Why am I putting them in ascending order? Because that's how we're going to be able to find where the median is. Okay? You see, if we have them in ascending order here, we could find the median, we could find the mean, we could find everything that we need. Okay, so now the median is 6, good, and that's going to be helpful for something later on. Okay, I still want you to always put in least to greatest. When we talk about outliers, we're going to come back and revisit MAD from another perspective. But for today, yes, this is the median, but now what is the mean? Let's find what the mean is. Let's go ahead and take, oh man, I wrote on this paper. I didn't mean to. All right, let's go ahead and take all of our points. 2 plus 3 plus 6 plus 8 plus 9. And then to find the mean, what am I going to divide that by? Somebody in the chat or on your hand, show me. What am I dividing all this sum by? What am I going to divide it by? Good, Cadence. Anyone else? Good. Wow, too many people. Rocco, Sienna, Arnold. Yes, Sophia. Good. We're going to divide by 5 because there's 5 points. To find the average of these 5 data points, I add them all up and I divide by 5. So let's see what we get. We get 2 plus 3 plus 6. Whatever. I think it's 28. Let me just do it. 5 plus 6 plus 8 plus 9. 28. 28 divided by 5. And what do we get there? 5.6. 5. Yeah. 5.6. All right. So we have our mean. That's going to be the key number that we're comparing it to. So now we have our mean. Now we do the work. We put it in order. We found the mean. Now we find the absolute difference. So to do the absolute difference, I'm going to actually write down our step 3 here. We're going to find the absolute difference for each of these points. Now watch what I'm going to do. I'm going to rewrite all this information here. Whoops. 4, 1, 3, 5, 2. 2, 3, 6, 8, 9. I just rewrote my least to greatest values here. And this is where I'm going to put the absolute difference. Okay. So first off, what was our mean? Our mean was 5.6. So every single value here is going to be, we're going to find the difference for it. Watch what I'm going to do. Absolute value. 5.6 minus the difference. The difference is subtraction, minus 2. We're going to find the answer for that. Then we're going to go 5.6 minus 3. We're going to go 5.6 minus 6. We're going to do 5.6 minus 8. We're going to do 5.6 minus 9. Okay? We're finding the difference between the mean and our data points. And we find the absolute value because we're finding distance. We're finding the distance to 5.6. Just like the absolute value is a distance to 0. So now we're finding the distance to 5.6. All right. So you just go ahead and work them out. You get out your calculator. Maybe you need it for some of these, maybe not. We have 5.6 minus 2 is 3.6. The absolute value of 3.6 is 3.6. We have 5.6 minus 3. That's 2.6. The absolute value 2.6. 2.6. So the reason we're doing absolute value is right for this aspect, because now it's 5.6 minus 6, right? That's negative 0.4, but it's absolute value, so it's 0.4. Okay, remember you compute what's on the inside, then you take the absolute value. Essentially, it's just going to make the answer a positive answer, but it's important to see that that it's really just asking, what's the distance of all these points? What's the distance to 5.6? All right, now watch here. Let's see, 5.6 minus 8 is negative 2.4, so the absolute value of that is positive 2.4. 5.6 minus 9 is negative 3.4. Absolute value is 3.4.
I have a question.
Perfect. What's up?
Why did you make it positive, even though like for the 3 bottom ones, they should have been negative?
Yeah. The reason why is, remember, it's the absolute difference. It's the absolute difference, which is absolute value. These lines here are absolute values. So if I do take, for instance, this bottom one here, if you said, well, 5.6 minus 9 is negative 3.4, right? But remember, we were doing the absolute value of it, so that's why I got 3.4.
Okay, I understand.
Okay, so it's as if we have the mean in the middle, and there's all these values around it, right? We wouldn't say that this number over here is minus 4 and this one's plus 2, because we're trying to find just the difference to get to that mean. So, okay, Cadence, good. So look, we found the absolute difference. Good, check that off. We did that here. We found all the absolute differences. 1, 2, 3, 4, 5. Now find the MAD average. These are all the absolute differences. And now what we're going to do is we're going to take those and do step 4 right here, where we go 3.6 plus 2.6 plus 0.4 plus 2.4 plus 3.4. And then we're going to divide by how many? 1, 2, 3, 4, 5. So we get finally our MAD. Our MAD is, Cadence, you got that? Yep. 2.48. I'm going to let everybody go and figure this out. I got something different than both of you got. Okay. 3.6 plus 2.6 plus 0.4 plus 2.4 plus 3.4 divided by 5. Yeah, Cadence, you're right. I had done something wrong. 2.48. Okay. Now, what that is saying is if I have a bunch of points, on this, and the minimum is 2, the maximum is 9, right? What this is saying, get up there. What this is saying is we can make our box plot actually with the average instead of the median, but we're getting to that later when we get to outliers. More about that later. What this is saying is here is the average of 2.4. Here is the average of 5.6. And what it's saying is the average deviation from this average of 5.6 is 2.48 in both directions. So this would be a situation where, it's pretty far spread out. If the MAD was, say, really small, situation, if we ended up with a MAD that was 0.5, that would be one of these guys. Here's my average 5.6. That would be a situation like this, right? So based on our MAD, it's talking about how spread out it is. The MAD is how much it deviates from our average, okay? And again, we in box plots are talking about this as the mean, right? As the median. But we're also going to learn later how we can make box plots look at this as the mean as far as the average goes. So all this is saying, I just give you a representation of where this fits. Yeah, there are a lot of steps. Calculated errors are the main thing with this. We're running out of time here, so I'm at the end of the video. But we will definitely be looking over this on Thursday. Okay. All right, give me a final thumbs up, sideways down. I mean, the MAD is the hard part, right? MAD's the hard part. Good. All right, so remember, this video will be posted later today. You can review it before you do your homework. I'm going to go ahead and stop the video. Thanks for watching.